So we just have a handful more practice questions to do. So let's get started. Okay, so compound interest. We know where we're going with this. There's our formula. 15,000 is the amount we're putting into it. The annual percentage rate is 2.75%. So let's move the decimal 2 places. So that's 1 plus, that never changes, the same, 0.0275 would be that decimal written, or that percent written as a decimal. 12 because it's compounded monthly, and the 12s match. They always will, because the ends match in the formula here. The 12s will match in the compounding monthly here. And 5 years. So that's 15,000 times 1.0022916667. Just punch those numbers in the calculator, it'll give you that, to the 60th power. And that works out to be $17,208.32. All right, so something that we've worked a little bit on, but haven't been as thorough as we could have been, and I'm going to have to make sure that I include a little more about this in the pre-test. There is a question on the quiz like this. We actually have 2 slides that are like these with powers and roots, so there'll be one in the quiz like this, and there'll be 1 or 2 on the test like this. So here are your basic exponent reviews, that like 2 to the 5th means 2 times 2 times 2 times 2 times 2. In other words, there are 5 factors here, 5 2s, and that's where the exponent comes from. It's real straightforward. I was working with my niece and her friends on that, and they're in 6th grade. Anything to the 0 power except 0. Anything to the 0 other than 0 is 1. So like 7 to the 0 is 1, 99 to the 0 is 1, 2 halves to the 0, 2 fifths to the 0 is 1, anything is 1. If you get a negative exponent, then that means reciprocal, so it's 1 over a to the n. If you're multiplying with a common base, you add the exponents. If you're dividing with a common base, you subtract the exponents. And if you are raising a power to a power, you multiply those exponents. Okay, so some example questions. Go ahead. All right, so these shouldn't have been too hard. You have examples there on your left. Expressing 3 to the 5th, that's 3 times 3 times 3 times 3 times 3. God, I'll never be a vocalist. Anything to the 0 is 1, including 9 to the 0. Anything except 0 to the 0. Evaluate 4 to the negative 2. Oh, negative exponent. That means 1 over 4 squared, which is 16. So it's 1/16. Next one, we're going to add our exponents. So that gives me x to the 9th. Next, we're going to subtract, not divide, subtract the exponents. That's n to the 8th. And number 6 is, when you raise a power to a power, you're going to cube the 3, because that's the coefficient. So that is 3 cubed for 27. And then n to the 15th. Okay? Here are some more, this time dealing more with roots. So square root means number times itself equals. So the square root of 4 is 2, because 2 times 2 is 4. Square root of 81 is 9, because 9 times 9 is 81. Cube root of 27, that means number used as a factor 3 times. It's 3, because 3 times 3 times 3 is 27. And the 4th root of 16 is 2, because 4th root, 4 times. 2 times 2 times 2 times 2 is 16. The other thing to keep in mind, fractional exponents, if you have the nth root of x, it's x to the 1 over n, okay? And 64 to the 1/3 would be the cube root of 64. So with those guiding principles, the cube root of 64, which is 4, because 4 times 4 times 4 is 64. So with those guiding principles, let's try these questions. And remember, between all of this exponent stuff, there is a question on your quiz that will deal with it. Okay. So, anything to the 0 is 1. So 11 to the 0 is 1. 5 to the negative 3. Oh, negative exponent. 1 over, or reciprocal, of 5 to the 3rd, which is 125. Square root of 289. Not everybody walks around with this off the top of their head, but if you punch it into the calculator, square root of 289 is 17. Express with an exponent, the square root of n. Now, when we express this with an exponent, we would say it's n to the 1/2 power. And the story I told you the other day is, well, let's do the next one, then I'll remind you of the story. The next one is n to the 5/8, because the root is 8, and the power is 5. And the story I told you is to remember back to kindergarten when you would do those idiotic plays in school, and kids would get the weirdest parts. Like, some kid would be the rock, some kid might be, I don't know, a bird, and another kid could be a tree. So I picture a kid being in a tree, and like they cut out a hole for his face, and they got the 2 arms sticking out in the branches, and the kid's only lines are this: the roots of the tree are down, the power is in the leaves. The roots of the tree are down, the power is in the leaves. So the root is down. So remember, the root is on the outside here, it's 8. And the power goes up top because the leaves are up top. So it's n to the 5/8. On the previous one, it's n to the 1/2 because it's a square root if we don't show anything. That's why the 2 is on the bottom. And the exponent, when we don't show it as an exponent instead of a root, is a 1. So that's n to the 1/2. It's a cool way if you're on a calculator and you want to find the square root of something. You could type in, for example, in number 3, you could type in 289, up arrow, the caret symbol, 1/2, and it would tell you 17. That's another way of saying square root. Okay, last one, number 6, express with an exponent. The roots of the tree are down, the power is in the leaves. So the roots are down, so that means the cube goes on the bottom, and the power, which is the v is being raised to the power of 4, goes in the top. So n, or v in this case, I should have said, to the 4/3. All right, so the last thing I want to do is just hit you with a little bit more review questions for these equations. And I actually have 3 such equation slides for you, 3 questions per slide, and then we are done. So, go ahead. Okay, so this is an opposite side, opposite operation situation here. Always start with a smaller number of n's. That way you keep your variable positive. Minus the 2 n's from both sides, that's 3n minus 8 is 40. Adding 8 to both sides, 3n's 48. Dividing by 3, and you get 16. Okay, the next one looks somewhat similar, but there's a number outside the parentheses. And though there are times when you do not need to distribute, you will never be wrong when you distribute. So for now, I strongly suggest that you begin such problems. You see a distribute, you go ahead and distribute. So distributing the 7 and then solve the problem from there. 7 times v is 7v. 7 times 3 is 21. Equals 3v minus 15 is what it should say. Of course, I wrote negative 11 there, and I should not have done that. Negative 3v from both sides, 4v plus 21 equals, and now notice I did put the correct negative 15 there. So sometimes I just miss a step when I go back. I should have changed everything to negative 15. I only changed the 1. You'll notice this is based on a previous slide. Subtracting 21 from both sides, 4v is negative 36. Dividing by 4, and I get v is negative 9. Next one, number 3. Again, as I just mentioned, we'll do stop and start, but I would distribute the 3. Distributing that 3b plus 9 plus b minus 1 is 2b minus 2. And we gave you a little bit more detailed explanation of this yesterday, but you want to combine your like terms here. If they're on the same side, you do the same operation. Same side, same operation. So 3b and 1b make 4b. 9 and negative 1, or 9 minus 1 is 8. So 4b plus 8 is 2b minus 2. Start with the smaller number of b's, subtracting 2 b's from both sides. 2b plus 8 is negative 2. Minusing the 8, 2b is negative 10. Dividing by 2, b is negative 5. Okay? All right. Let's try the next one. And do all 3 of these, and then we'll give you the answers to all 3. That way, I'm sure when I should start going over these. So, first one, subtract 2n's from both sides. 3n minus 8 is 19. Adding 8 to both sides, 3n is 27. Dividing by 3, n is 9. Remember, always start with the smallest number of n's. Number 2, you see a number outside parentheses. Go for it with the distribute. 5b plus, oh, that should say 15. Hopefully that's just a sloppy mistake that I correct in the next step. Subtracting 3v from both sides. Uh-oh, this is looking bad. Looks like I'm going to have made a mistake here. Sorry about that. But I will tell you the verbal correction for it. This 21, that should be 15. And that's going to affect things in a little bit. Subtracting 21 from both sides, I get 2v. And here's the thing. It should not have been a 21. It should have been a 15. So this should be 2v equals negative 30, not negative 36. It should be negative 30 here. Dividing by 2, and you get v is negative 15, not negative 18. I do apologize for not catching that sooner, but I am 10.5 minutes into this video, and I'm not going to go back and redo the whole thing. So I am showing you the correct way to do it. I'm just doing that verbally rather than by writing the correct step. Next up, distribute to 3. 3b plus 12 plus b minus 1 is 2b minus 3. Let's combine like terms. Get all those b's together. That's 4b, and I'll get the numbers together while I'm at it. Plus 11 is 2b minus 3. Subtracting 2b. 2b plus 11 is negative 3. Subtracting 11. 2b is negative 14. Dividing, and I get negative 7. Booyah! That is correct. So just remember, in that middle one, it should be v equals negative 15, not negative 18. Ding, ding, ding. Negative 15, not negative 18. Okay. Next up, there you go. Okay, looks like the time for stop and start has ended. Always start with the smaller number of ends. Minus 3 ends from both sides. 2n minus 8 is 42. Adding 8 to both sides, 2 ends 50. Dividing by 2, and ding, we get n is equal to 25. Nicely done. Distribute. Distributing the 7. 7v plus 21 is 3v minus 11. Let's see. Subtract the 3v from both sides. 4v plus 21 is negative 11. Subtracting 21 from both sides, I get 4v is negative 32. It's worth noting here that when you get rid of that 3v, danger, danger, danger. Don't lose track of the fact that that 11 is negative. Some people will let that negative sign drift off into oblivion and just keep it positive. That is a mistake if you're doing that. So 4v is negative 32. Dividing by 4, b is negative 8. Number 3, as I said, always a good idea to distribute right away. 3b plus 9 plus 4b minus 1 is 2b minus 2. Let's collect everything that's alike on the same side by combining like terms. Same side, same operation. 3b's and 4b's make 7b's. 9 and negative 1 make 8. So subtracting 2b's from both sides, I get 5b plus 8 is negative 2. And there's another example of that, with that 2 being negative, that we did not lose track of that through the problem. It stayed negative. I didn't let that become a positive 2. You make that mistake, you'll get it wrong every time. Subtracting 8 from both sides, 5b is negative 10. Dividing by 5, b is negative 2. That, folks, is our review. And that's a whole lot of stuff that's going to be on your test and on the quiz that you take today.